How does ATP synthase actually combine an ADP and an ATP? What's the structure and function? Here is a membrane showing the cylinder, the membrane-embedded portion of ATP synthase. Down below is a shaft that's attached to the cylinder, and a series of 6 subunits that I'll show in more detail later. Right now I'm just showing 2, and then a stabilizing element on the outside. There's a concentration of protons. In other videos I've shown the half barrel that moves them through, and the mechanism that rotates this cylinder. So the whole cylinder rotates, and that rotates the shaft. In the shaft, ADP and phosphate attach and are pushed together. Remember, ADP is a -2 and phosphate is a -2. It takes a lot of force to get those together to form an ATP. That force is created by the proton motive force that includes both the concentration gradient, pH 7 up above, and pH 8 down below in this video, and the -150 millivolt charge. So the initial force is provided by the rotor, and then the lower part shown here is where ADP and ATP are actually bound together, forced together for synthesis. Here's again the rotor and the location where ADP and phosphate bind. And if we looked at it from below here, we'd see the 6 subunits, roughly triangular in shape, with a central portion, the central shaft. There are 3 beta subunits and 3 alpha subunits. And these are the areas where ADP and phosphate bind. And in the B subunit, according to a hypothesis I'll step you through, the phosphate binds in one location. This is a schematic, and the ADP shown at the bottom in another. Remember, the phosphate PI is -2 and the ADP is also -2 charge. It is not easy to force them together and form a covalent bond. So in the next part of the video, I'm going to show you a simplification and a hypothesis for how they bind. There are some models and some 3D structures that exist, but the full details, at least so far as I can find, are not yet known. So here's a schematic, not intended to represent exactly what's going on, but I've shown the shaft there, the gamma subunit, that rotates against the B, and I've put a dot on one of the parts of the shaft to help us keep track of where it is. There's a binding site for ADP, and that first step is the shaft pushing against it and opening up the binding site for ADP. So here's an ADP bound. The shaft continues to rotate as protons move through the cylinder. So now I've shown the shaft in a different position. The black dot has moved. And at this stage, with ADP bound, a binding site for phosphate opens up, and PO4 -2, I haven't shown the minus charge here. In the next stage, the shaft continues to turn, and now ADP -2 and phosphate -2 are forced together. And that's the action of the shaft turning against the base there. I've shown it making one more partial revolution. And I'm going to put it in red because it takes a lot of physical force to push the -2 charges together to form an ATP. That force is provided by the gamma subunit turned by the rotor up in the membrane. So if we go back to our original image, we're seeing the rotating gamma subunit, which is forcing ADP and phosphate together, powered by the rotor and allowing ATP to form.